So by the way, let me ask you this. So what is the difference between pig and hive? Can you tell me? Whatever we have learned based on that, can you just identify the difference between pig and hive? Yeah, anyone wants to share anything on that? This is a simple question, everyone. I think you should know about it. Nobody is responding. Why is that? I asked the question, Mano, that what is the difference between hive and pig? Yes, very good, Raj and Shiva. So, Hive is used to analyze only structured data, whereas Pig helps you to analyze both structured and unstructured data. That's the only difference. In fact, any other difference, if you would want to find out, you will not find anything, because as we learn, Pig is actually, of course, yes, Pig is using a different scripting language to analyze the data, which is called Pig Latin, and Hive is using a query language called Hive Query Language, which is more like SQL, right? But that doesn't really make them different, because it all depends on the people and their comfort level and their skills. Some people might find SQL very easy, whereas some people find Pig scripts very easy, Pig Latin very easy. So that's why we can't say that, one is better than other because of the language that they use. So development wise, both are actually giving you, a faster development in case if you are familiar or comfortable with that language. But the most important part is the data, that type of data which it can analyze, right? Internally, yes, both of them will convert their respective queries or scripts into MapReduce programs and then execute it on the Hadoop cluster. So to process the data. So of course that is why it is definitely used in the MapReduce way, and it can process the data in a distributed manner. So both of them will take its own time. So performance wise also, as you can see, no difference at all. Both of them will be taking their own time, right? In fact, the UDF functionality, user-defined functions that we have seen in Hive, in Pig, we will also see it in Hive today, and that is also same. So Raj, it's the same guide where you can find those details, like Hadoop Definitive Guide 4th edition. That is the one book. And apart from that, in fact, if you really want to get more functions, then just say Hive functions or Pig functions, and you will get it on the Apache website itself. You don't really need to find out anywhere else. You'll get all the list of functions there itself. Okay, so was anybody was able to practice on Pig and Hive that we covered last session? No, Raj, that will not be able to show. That is not part of the agenda. That is something that we would cover in the admin training. And as I told you, right, I think you guys have actually taken the one past GLVC session where you can attend even the admin training with the same, pass. So you don't need to pay extra, I guess. And that's why you can try attending some admin session and where you will find out how to, you can learn about that topic. I think in just about a minute time it should be started. Then we can continue with the Hive. Yes, Mary. All right, cool. So let's go to the Hive session and let's understand what we are discussing. So one important thing which I wanted to tell you is, by the way, anyone remember where Hive, whenever we create Hive tables, where does it create the data? No, Raj, it will never work. I think there is something wrong you would have done. It cannot work if you change the method name from reduce to capital R reduce. That cannot work. It would have called the default, superclass method. And depends on your data type. It might have given some error. If it has not given error, then it would have called the default method logic, not your method. It has to be case sensitive. It is, you can't write capital reduce. Yes, I was just mentioning in Hdfs, basically under user Hive warehouse folder, you have this data, right? So I wanted to show you a few important differences here, which is if you go here, let me just show you that part. Right. So here under test4.db, in fact, we have created a database for books, right? Database called test4, and then we have created a books table, and under that we have created a books directory. So let me just show you one important concept called internal and external table. So to log into Hive, you need to just say Hive. Okay. So I'll just say use test4db. Show tables. It could show me the tables called books. Now let me drop this table. So by the way, the table that I have created, right? I have created a normal table, right? Using create table syntax. Now if I want to drop it, I can easily drop it using drop table. And when we drop it, what happens? It can actually go and physically remove the data from the Hdfs. So that is one point. And then if I do select star from books, you can see that it says error. It says table not found. So basically your data from Hdfs, your physical data from Hdfs gets deleted, as well as your data from metastore also gets deleted, right? In your metastore you store metadata about tables, so that will also be deleted. So that is what happens in case of internal table. This is called internal table, which means it is internally managed by Hive engine. So that table creation and table deletion is completely under the control of Hive engine, which means whenever you create a table and then if you drop the table, it will also go and drop the data from the Hdfs. But there are some cases where, let's say, you have created a table, you have loaded huge amount of data, and now by accidentally, let's say someone goes and deletes the table, then what happens? Even the data gets deleted, right? So you might lose the data, which was a very, very scary part. And that's why Hive has come up with another concept, which is basically called external tables, where they will allow you to preserve the data even if you drop the table. So how do you do that? Basically, so let's say I'll actually quickly show you another example of a data. Basically, we have just one second. We have one transaction file, and let us create a table which can load this data, which is transaction ID, user ID, amount, product, city, and date. So I'll just say create table transaction. Okay. Transaction ID, user ID. All right. Oh, this is date, not the payment mode. Let me give a good name, product order, and I'll just say this is order date. Okay. Okay. So we were able to create the table. Now if I do select star from product order, I should be able to see the data. But right now there is no data. Earlier there was an error came because I forgot to put integer type for one of the columns. So now it's working fine. Now this is an internal table, right? Which means, let's say if I also do this load data local in path. Okay. Now you get all the data. That's fine. So we have created a table. We have loaded the data in Hdfs. What happens? You would see the table, and under that you will see the file. Correct? So this is fine as of now. Now if I drop the table, what happens? Your data should also get deleted here, right? Nothing is there. And if I do select star, it says table not found. So this is called internal table. When you delete the data, in fact the table also gets dropped, and the Hdfs data also gets deleted, metadata also gets deleted. But as I said, to prevent this from happening accidentally, and to lose data, to basically save data even in case of you drop the table accidentally, there is a concept called external table. So you can actually create some table as an external table. So let me create a table now again, the same table which I have created. I'll just put one keyword here, create, and then external. That's it, no other change. And then I'll load the data as it is in that table. Everything is fine, then I'm selecting the data. That's it. So you could see that the data gets loaded. Here the folder gets created and the file gets copied inside that folder, right? With the data. So it's fine here. Now let us drop the table. If you drop the table, what happens? If you see, the data it is still available. It's not yet deleted, right? Which means your data is persisted. It's not deleted. Only the metadata. If you do select star from that table, it says table not found, which means only the metadata gets deleted. Data in Hdfs is still there. It's not deleted, right? That is what we mean by external table. So that is the difference between internal and external table. Is everyone clear here? Did we understand this concept? Any questions on this? Nothing. If you can just say create table again, okay? This time you can still create an internal table only. Even if you create external table, it's fine. Just if I do create table and just say select star, it will give me the data. Automatically the mapping has been restored just by creating a table. Because in the same location physically in Hdfs, that table is pointing to the data, right? So you don't need to worry. If you just create the table itself, it will point that same data to that table, and then you can start reading the data on that table. So Raj, if you drop the table now, then what happens, since it's an internal table that I have created, it will delete everything, right? It's the same thing actually. So here, if you go and check, the data gets deleted, as you can see from here, right? So now you need to create it again and then do all the operations which we have done again. Yes, any further questions on this? That you have to check on the query itself, Nikhil. There is no way we can check it after that. Alright, so let us now see the different types of queries. By the way, all types of SQL queries are supported, and hence I am leaving you with, I mean, there are a lot of options you can explore, like where condition, order by, and all, which you can always try it when you practice it. I am just going to show you one join query so that you will understand how join works, and that contains where condition and everything. So, we could cover at least one complex query that way. And then I'll show you some other data as well. Just one second. There is a customer file and there is a transaction file. I want to join them, and I want to find out one interesting information, which is the maximum transaction done by every user along with his email address. That is what I want to find out. So we already have loaded a transaction data. Now let me create another table called customer. Okay. And then I'll just say customer ID. Okay. So we got all this data from the customer table. We have, if you see the product table also, that will have transaction data. If you want to join these two tables, right? You can have a common column which is a user ID, customer ID. So you can write a query to find out the maximum transaction done by a particular user along with his email ID by joining these two tables, right? And that is what we are going to write. But I have already written a query, so I'll directly show you that query itself rather than rewriting everything. So what's happening is basically you select the email address and the amount field, find out the maximum of amount from the product order. Then creating an alias T, joining with customer U, and then you just say on the columns, join on the user ID columns for both the tables, and then you say group by user ID and email. That's it, right? So if you execute this query, you can see that it will internally convert it into MapReduce and then give you the result. Yeah, it is executing it as a MapReduce and then it will give us the data. Alright, so as you can see that we got the data for the maximum amount spent by a given user along with his email ID, right? So this is fine. This query will work, and we have seen how the query gets executed in Hive, even the join queries. And now for that matter, you can do left outer, right outer, all types of join here, right? So I'll leave it to you with those exploration. Here, important point is, let's say you want to get the data out of the Hive and store it in local file system. That means the output of the query, you want to export it into the local file system. So you can do that based on, there is a keyword called insert override directory. Okay. So what you can do is here, insert override local directory means I'll be creating a directory called join data inside this, and then whatever is the query, that the result of that query will be stored in this directory in the local file system. So if you execute this query, again it will be a MapReduce, but then it will export the data into the local file system in this directory, right? So this is how you can export the result of any query into the local file system, and then probably you can take it to the any other system and do any other type of analysis as well. So Nitin, this is basically the kill command is actually to kill the MapReduce job. As you can see here, this kill job ID. Basically, it just says, so this is the command you should say Hadoop job -kill, then the job ID, which will kill your MapReduce program. See, every MapReduce program internally gets converted into MapReduce. Sorry, every Hive query gets converted into MapReduce, and that will assign a new job ID. So let's say some queries you are running, and it might be possible that query gets into hung state, or it will take more time to complete and you want to kill it. So this is the command it will give you. So if you just execute this command, it will kill that execution. Okay. Okay. Let us go back to the Hdfs, local file system, and see the data. Join data folder gets created. There is a file which has this data. Okay, an email address and the maximum transaction done by user. So that's how we actually could export the data from Hive into the local file system. Right. So is that clear, everyone? Any questions on this? All right. So now we will actually look into one more concept, which is a UDF function, and after that we'll see the partitions in Hive. Okay, post which we'll get into the next topic. So the UDF functions are the exact same that we have learned in Pig, right? If you remember Pig UDF. So we have actually created a user-defined functions where we wrote code in Java to solve some generic functionality, and we used it in pig queries or pig scripts. Similarly, in Hive also, you can do the UDF for the same purpose, exact same purpose, right? No changes here, right? And it would basically help you to achieve the same thing, which is you can make it as more generic, and then you can try to execute it as a generic function so that that can be called by multiple Hive queries. And of course, some tasks you cannot achieve using Hive queries, which you can achieve using Java. Hence, you want to write that code in Java and then call it in Hive. So that is where UDF function gets UDF functions are required. Okay. So let me create a class called Hive Udf Demo. We'll be doing the same thing actually. We'll write the functionality to convert anything into uppercase, let's say. That is what I want to do in Hive Udf as well. Alright, so we basically start writing the code here. Hive UDF has to extend the UDF class, which is from Hive. You need to also import the jar, by the way, here. For jar for Hive. So we can just import it right now. We will go to the build path, then configure build path. And here you can say add external jar, user lib, hive lib, hive execute dot jar. Okay. Yeah. So it got imported. Now we'll start writing one method, which is called evaluate method. All right. So what I have done here is I have overridden one method called evaluate, which expects input as a string. First, I'll check all the basic basic validations, like if it is null or if the size is 0, then return null, don't do anything. Otherwise, you create a new result string, set that as an input string, convert it into uppercase, and then set that uppercase as a result string and return that result. That's it. Basically, whatever input I'm getting, I'm just converting into uppercase and returning that result. That is what I'm doing as part of the Hive UDF, right? So I'm sure it's easy to understand this code. So now we will understand how do you call that UDF, right? How do you basically call the UDF functions to use that. So let us write a Hive scripts. Now instead of writing Hive scripts from the Hive prompt, I want to write it outside. Okay. So let's say I'll just say Hive Udf Demo .q. I also told you, right, that there are multiple ways you can execute Hive queries. One is logging into Hive shell and then executing queries one by one, which is more like interactive analysis. But you can also, which is also more like ad hoc analysis, but you can also do one thing where you can create a Hive query and then rename it as .q file and then put all your Hive commands inside that. Okay, and then execute it as a batch query. So let us see that example also. We'll see both the examples, how to call UDF as well as how to basically use batch queries in Hive and execute it without logging into Hive prompt. So here the first thing is you need to add, okay, by the way, one important thing, when we want to use any UDF function, right, which is written in Java, I have to export it as a jar. I need to have a jar file available with me. Let me write it as hiveudf.jar. Okay, and then I will call it here. So I'll just say add jar, then your jar path. Okay, so you have added the jar file. Then you just say create temporary okay. What I'm doing is, now I need to create one function name, okay, which is toUpper. I can give any name here. And then I'm pointing it to the class in this jar file. This is my class com.hiveudf, right? See under, if you see here, under the com package, I have a hiveudf class. So I need to point it to that particular class. So what I'm telling is, I'll be creating a function as toUpper, which will internally call the code or the logic written in this class, which is available in this jar. Okay, now you can directly use it in your Hive queries. Let's say I want to use it something like this. Select to, I want to convert a particular column, let's say called product, from product order. Okay, what I'm doing is, if you observe here, let me log into Hive. And parallelly, I'll show you the data of the product order table. So here, as you can see, there is a product order table where one of the column called product is not in uppercase, right? It's everything is small case. So I want to use that column and convert every data of that column into the uppercase. All the rows of that column has to be in uppercase. So that is, to do that, you will write this UDF, right? So I'm just calling these two upper functions and passing that entire column. What happens? It will go through each and every row of that column, convert it into uppercase by applying the logic written in this class, which is available in this jar. All right. So let us save this file, okay, and then execute it as a batch file. So as you can see, I'm not logging into Hive prompt. I'm directly calling this batch file, which is Hive Demo Udf Demo.q. Okay. If I execute it, you can see that it will give you the data. It will give you the result. As you can see here, I got all the product data converted into uppercase, right? So that's how you can basically use a UDF. So Mary, it was done internally. We have written it outside, right? We have called it from the outside Hive shell. That's why you don't see that. But it is internally, it has done that. Okay. Yes. So any questions on Hive UDF? How to use it? Yes, Mary. That is definitely possible. This is just to highlight you that how to execute it as a batch query. You can also execute all these queries in Hive as well. All right. So now we will move on to the last topic, which is partitions in Hive. Okay. How do you create partitions? So let me just open the whiteboard and explain you what is the partition, and then we will basically understand about the practical demo of that. So by the way, okay, let's first understand the reason for having a partitions. Okay, so let's say I have a table called transaction in RDBMS. It has multiple columns, and one of the column is, let's say, date, transaction date. Okay, and it has about millions of records. Now, if I want to find out, like, that there may be, let's say, many transactions have happened in this table, and a lot of transaction data are there. For example, let's say you want to find out the maximum transaction done on a particular user by a particular user, then you can get it. Or let's say you just want to find out details like, I'm sure that transaction table also will have one of the column as date, right? So normally what happens in RDBMS table, many of you are already aware of that, that whenever you have any table which contains huge data, there will be a lot of columns in that table where indexes will be created. Okay, so some of the columns will have an index created on that, so that we can retrieve the data faster from that column. Okay, so normally tables like transactions which are more which are basically having date, definitely a date as one of the column, and when people want to see or retrieve the data for the transaction table, they will definitely write a query which contains where condition, where definitely date column will be used mostly. So what I'm trying to highlight a point is, whenever you need to retrieve a data from the table where your filter condition needs one of the column very often, that column should be indexed, right? That column should have an index created on that. So normally RDBMS database administrator, database designers would do that, right? So we don't need to worry about it. Let's assume that there is a date column in the transaction table which is already indexed. Now there are 1 million records. And since this is actually a Diwali time going on, right? In India, it's a big festival. Let's assume that how many transactions has happened on during the Diwali, right? That is something that I want to find out as a merchant. So what is the query? The query will be very simple. Select star from that table where the date is, let's say, whatever, 11th November is a Diwali time. So let's say 11th November. But when you execute that query, since it's an RDBMS table, obviously you can get to see your data very fast. You can retrieve your data very fast, right? Because that column is indexed. What if the same data or same query you want to fire it in Hive, right? Well, when we bring the data from RDBMS into Hive, when we want to do analysis in Hive, how do we do it? I'll show you the next topic, which is Sqoop, where we'll understand how do you bring the data from RDBMS into Hive table directly. But ultimately, when you store data in Hive also, what happens? Internally, it will be converted into it will be stored in the Hdfs only, right? So let's say we are bringing data in this fashion. User Hive warehouse, under which I'm creating a table called transaction, under which you will have you will have basically a file with all these different transactions, about 1 million, right? Normally this is how it gets stored, and that is what we have seen so far. Now in this case, in the Hive, when we create a table, we all know that we can't create index on the Hive table, right? There is no index creation supported, no primary key concept exists. It's a plain flat file where you are storing the data, and then if you want to do the analysis on that table, like select star from that table where date is 11 November, because the date column is not indexed, it has to go through all 1 million transactions from that file. Every record in this table it has to go through, and then whichever record it matches with the date as 11 November, that record it will basically show you, right? So here also it will give you the correct result, but the problem is the retrieval of the data is very slow because the column is not indexed here, right? That is the important difference between Hive and the table, the transaction table. Excuse me. All right. And another difference is, this is actually one major difference, which is where the Hive queries will take more time to return the result compared to RDBMS queries. Because of the index creation in RDBMS tables, it can retrieve the data faster. In Hive, it is not possible, so it retrieves slower data. Apart from that, there is one more difference. Like, let's say in a table, I am having, let's say tomorrow is 12th November. Of course, tomorrow also some transaction would happen, which is on 12th November, right? So what happens when the transaction happens on 12th November? There are, let's say, about 1,000 new transactions which came in this table. Of course, you can append this transactions into the same table, right? You don't really need to do any further changes. You can append the data into the same existing table in RDBMS. But in Hive, we can't append the data, right? So what if I want to bring this 1,000 transaction into the same file? That is not possible. So that is also one more problem with the Hive tables. You can't append the data into the already created table in Hive. And in that case, how do you solve the problem? You have to first drop the table here, and then you have to recreate the table by reloading all the data, which is not a very efficient solution, right? Every time I can't, delete 1 million transaction and then add 1 million plus some X number of transactions. That is not really a good solution. So these are some of the challenges which were there with Hive. Okay. So did you all understand these two problems? Any questions on these challenges or problems that we discussed so far? All right. Now, how do we solve this problem? These are the two challenges we have in Hive table, but then how do we solve that problem? So for that, we have to basically use one of the functions in Hive, which is called partitions. Okay. So what is a partition? Partition is a concept in Hive which they have developed to solve this problem, which is basically nothing but what you do is, see, it's just like a normal database partitions, and I'm sure you know about database partitions. It's just, it's like creating a partition as a column itself. So in Hive, you can choose one of the column as a partition column, right? In the table, when you create a table in Hive, you are saying that this column of this table will be a partition column. After that, automatically when you load the data, it would store them as different partitions. For example, let's say this table, transaction table, when I'm creating, when I want to load data from transaction table into Hive table, I have to be, as a Hive database schema designer, I need to make sure that there will be a lot of queries that I'm going to write on this table, which will involve date as one of the filter criteria. So definitely I should use date as my partition column. Which column to be chosen as a partition column is completely dependent on your business requirement. So let's say I'm choosing date as a partition column. In that, what happens? It will create date as, let's say, 1st January and create a directories or a file which will contain only those records which occurred on the date as 1st January. For the 2nd January, it will create one more folder or one more directory with this name. Date is equal to 2nd January. Under that, it will create a file with that transaction. Likewise, all the dates till November, you will have different directories created. Now you have, let's say, 10th November, under which it will have a file which contains that much data. Again, you will have date is equals to 11th November, under which you will have a file which contains data on the stores which are available for 11th November, and so on and so forth, right? So basically, in Hive, right, when it stores the data, it actually creates multiple partition directories. Date is equal to 1st Jan, 2nd Jan, and so on and so forth. And it stores only the data for the, it creates a file within that directory which contains only that much data, or that those records which happen on the 1st January or 1st November or 10th November. So basically that way it is trying to separate out in different directories. Now what happens, what is the advantage of doing it? Now if you want to, let's say, do this, select star from Hive table, let's say transaction table, you want to query all the data from transaction table where date is equal to 10th of or 11th of November. Then what it does, it doesn't need to scan through all these partitions. In fact, it just goes to this date is equal to 11th November and just read this much portion of the data which is stored in the 11th November directory. It doesn't need to scan through any of the file available here. So what you are doing here, indirectly you are in fact creating the index only, right? And so that your retrieval of the data becomes faster if you have partitions. So that's the major advantage of using a partition. So you can actually simulate index-like behavior on Hive tables, right? That is one important part. Another thing is, let's assume that I have this data loaded. Now tomorrow, as I said, 12th November data gets appended into the table. I can just create another directory called date is equals to 12th of November. And it would create that particular file. So you don't need to really worry about changing the existing file because it is anyway not possible. So what it does, it will create a new directory and it will copy a file with that much data on 12th November, right? So basically, that is how you can append the data. Update is not possible, Nikhil. Only append is possible, okay? So that's how basically you can append the data in Hive tables. So these are the two use cases of the partitions that we use in Hive. So now if I do select star from transaction table, it will go through all of this directory, fetch all the data from this directory and then give you the result. Why? Because in the meta store of Hive, it remembers that all these directories are part of the partitions under transaction table. So that's why it goes to all the directories and read all the files from that and then give you the data, right? So this is the use of partitions. Is it clear with everyone? Nikhil, are you clear with your question? No, Nikhil. If you delete it from underlying HDFS, no error will be reported. It's like a physical delete. So it is possible. Fine. I'm sorry, Nitin, actually. Yeah. Cool. So let me now show you the result. I mean, not exactly result, but the demo of how do we use partitions, right? So there is, by the way, a file that I have created. I'll share it with you at the end of this session, which has 4 simple steps of creating a partition demo. Okay, and you can just execute it as it is. So first of all, when you want to create a partition, you have to set these 2 properties. Okay, so under Hive, I'll be setting these 2 properties as true. Set Hive dynamic partition as true and the mode is non-strict, so that only it will create a dynamic partition, by the way. Now what I do is I have to create one product order table, load data into that. I have already done that. I already have a product order table and I have loaded the data inside that table, right? Now what I will do is I will create another table, as you can see from this query. Create table, dynamic partition table, and it has these columns. But one of the column order date, I have to make it as a partition column. So that's why I'm defining it as partition by, and I'm specifying one column here, right? Now, if you do, let's say, describe of dynamic table, sorry, partition table, you can see that all the columns are listed here, and one of the column, which is an order date column, it also mentions that it is a partition column, right? So basically, even the partition column is part of the table only, but just that you have to specify it as a partition by. Then only it will act it as a partition column. As partition column. So are we clear? So that is how basically you create a partition data. Now here, this is just about creating a table. So if I go to the HDFS, right, and if I see, I have both the tables created. Dynamic partition table is empty right now. Now what I want to do is I want to, let's say, I want to load the data. So what I'm doing, this is one more way of loading the data into a table. Remember I told you on that other day where we can load the data from one table into another table, right? We can just say select data from one table and put it into another table. This is the query for that. You are saying, so I'll be doing this. Insert override table, dynamic partition table, partition date column is order date. Then you are selecting all the columns from the product order table. Alright, this is what you are doing. So you are basically reading the data from one table, putting it into the dynamic partition table where the date, the partition column is order date. Okay. For example, if I just want to do this select star from product order, you will see that these are the data that product order table has. But now when I want to copy it into the dynamic partition table, it should internally in this HDFS, it should create a directory automatically for every date. Every date in the sense all the unique dates. So if there are 1st January has 2 records, it will just create one date 1st January and create a file within that which contains 2 records. Similarly, if there is a 3rd April date which has 3 records, it will create a partition directory as 3rd April, but under that it will create a file which contains 3 records. It should do it automatically. So let me do this. When I execute this query, we'll see it will automatically create those 3 partitions because you are defining that this is my partition column in this table. So when it loads the data, it also creates a partition dynamically and then copy the data into that table. Alright, so as you can see here, it basically has created, loaded the data, created these partitions, three different partitions. So let us go to the Hdfs and see first of all. If I refresh, as you can see, three directories are created because there were three unique dates in that data. Okay, every directory will have its own file, right? If you go back here, this directory will have its own file. If you want to physically check, you can check it like this. So I'm going to read the data contents of this file under 3rd April directory. It should have only three records. As you can see, it has three records, right? We can also cross check it here just by doing this. Select star from dynamic partition table where order date okay. So you got these three data. So here, as you can see, product EFG, product EFG. So we are good. You can also check with another partition directory. The file, it will contain only those two records which has come for that day, right? So we are going to see it in one of the other partitions, which is 1st January 2015. As you can see, you get two data, product A and product C. Here also, I'll get this, product A and product C. So we are good here, right? So basically, that's how you create partitions, and that's how you use partitions. And you use it in where condition, the retrieval will be very fast. So Nikhil, the partition is the concept which is provided by Hive itself. We can't use it outside Hive. Another important thing is you can have a nested partitions. So you can have partition within the partitions, like month, year, date, everything as the partitions. Yeah, that's what I'm saying. So it depends on what partition you want to select. You have any partition span column, you can actually create that column as a partition. So that's fine. That's not a problem. That's why I said that which column to take it as a partition, it completely depends on your business requirement. If you want to, let's say, take in the same example, let's say this is my table and I want to actually, just one second. Let's say this is my table which has this data. I want to now create a partition from like in a January month or a February month or April month, month by month. Then you can choose a month as a partition and all the date within that month will be put it into one file, correct? All the records. So it's completely possible. Is that clear? Okay, fine. Yes. Any more questions anybody has on the partitions? You mean to say select the dynamic partition table? Oh, on Hdfs. Right, sure. So this is a dynamic partition table, and in the product order it doesn't have any partition. It will have only one file which contains all the data. In the dynamic partition table that we created will have three directories, and inside that it will have its corresponding files. Clear? Is that clear, Nitin? No, that is what we wrote the query like that, right? See, this is the query we have written. Insert override table, and then we gave the column as partition column, and we are selecting all the other columns from the product order. So the way you have written the query, based on that, it will populate all the data for that columns respectively. It will be the same, Vishal. I mean, it will be like, you just need to add the data again. It's like I mean, when you are loading the data, just use the same insert override table and select the data. Now, whatever table you have the data, that will get created, that will create a new partition. So there is no change in the query. Same query you are going to use. Are you saying this data problem? How do you know the column? You can just do describe, right? It will show you the column order. I'm sorry, is this what you're asking? Okay. All right. Any further questions on this partitions? So Mary, partition table has order date. If you do describe of, sorry, if you do describe of Hive partitions, there is a order date column here. But when you store the data physically, it will not put order date column inside this data, because it has already created a directory itself with that date value, right? That's why. So partitions data will be used to create a directories, not to store it in the file. Clear? All right. So that's what we had for Hive. Now we'll basically move on to the Sqoop. Now we'll see two components, Sqoop and Flume, very useful and very easy to understand components, right? So I'll directly show you the practicals on that. Normally Flume practicals we don't cover it in the session, but I'll show you the demo on Flume as well, so that we'll have an understanding about how do we import the data using Flume. All right. So let me show you the Sqoop demo. By the way, how does a Sqoop work? Everyone knows. Sqoop is just a component which helps you to import the data from a database into Hadoop. Let's say there is one table and I want to bring all the data from that table into the Hadoop. Yes, that's right, correct, Nikhil. So you basically bring the data into the Hdfs, load the data here. That is where Sqoop comes into picture. To import the data, no Vishal, logs will be imported using Flume, not via Sqoop. Okay, so Sqoop will help you to import the data from RDBMS into the Hadoop into Hdfs. It will also help you to export the data back from Hdfs to RDBMS. That is also possible. Okay, and we are going to see it how. So first of all, let's take one example of Sqoop import. Let's say I have a table, some table is there in my database and I want to bring that data into the Hdfs. That is the exercise we want to do using a Sqoop import. In that, let's see what happens. So the first thing which I want to explain is, let's say there is a table, the table name can be, let's say, customers or anything, okay? This table will have multiple columns, correct? And it will have so many records. I want to bring all these records into the Hdfs. Now, when a Sqoop tries to import the data into Hdfs, right? The Sqoop import command is there, which I'll show you how does it look and how do we use it. But any Sqoop import command will internally be converted into MapReduce. Okay. So why does it need to be converted into MapReduce? Because it can parallelly load data into Hdfs. So for example, let's say your table has about 1000 records and I want to bring all 1000 records into the Hdfs. So what Sqoop import command does, it will try to hit this table parallelly. It will open four threads to hit the table. Okay. By default, always Sqoop will create 4 map tasks and it will try to partition your table into 4 different portions, and each portion of the data will be scooped by individual map task. Okay, how does it partition? There will be one primary key column available on that table. Based on that primary key, it will try to divide your data. So from 0 to 25, or sorry, 250, it is given to one map. From 251 to 500, it is given to another map. Like that, it will give the different records to different map tasks. Now once this map task has this data, what they do, they will try to parallelly load this data into Hdfs. Yes. So the reason of having multiple map tasks is to make sure that you can write the data in a faster manner. That is why Sqoop import command will be converted into MapReduce internally. And by default, it will always take number of map tasks as 4. You can, in fact, in the Sqoop import query, you can choose to set a different number other than 4. You can also reduce the number that I want, let's say, only one map task. So that is also possible. Okay, and I'll show you how to set that. So is everyone clear with this? Any questions on this Sqoop import use case? We'll first try. So Nikhil, if you don't have index, then you have to specify one of the column at least which it can use to split the data. There is a split hyphen split by as one of the keyword, and you need to use split by keyword and put your column name. Whichever column you think will be more unique, that column it will use to divide your data. Okay. It cannot assume itself randomly. You have to specify one of the column in the split by clause in Sqoop import. So we are going to do first use case where we will import the data from the table and load it into Hdfs. So let me show you how do we do that. So there is actually already a command that I have written. I'll be sharing this, by the way, with all of you. Okay. So we are going to basically do this. So first, here I have mentioned some steps like how do you log into the MySQL database. In Cloudera VM, we already have a MySQL database installed, which is an RDBMS. You can log into it like this: MySQL-D, the database name, the user, and the password. Okay. So let me open that. Let me open a new terminal and let me log into that database. Password is Cloudera. Everything is written in this file, so you don't need to worry. See, I am already inside MySQL database. If I do show tables, it can show me all the tables which are already available. The important part of it is, let me drop one table which I will anyway create it again in the demo. Yeah, so important point to notice is already there are some tables which are already created by the Cloudera itself with a good data, right, pre-populated, so that it can be used for our practice. So let's say one of the table called customer, select star from customers. I'll have so many records in that table. I'll have about 12,000 records in that table. Okay, so I want to bring all these records in the Hdfs. That is the exercise I want to do. This is my RDBMS data. I want to bring it into Hdfs. Let's say under any particular directory, under anywhere I want to bring the data. Okay, so let us do that. Let me use a command first. This is the command I'm going to use, sqoop import command. I'll just say sqoop import -- connect. Then you can pass the URL to connect to that sqoop import, which is, as you can see, -- connect, and then you just give the URL to connect to the database, the MySQL. Since Sqoop is written in Java, you have to provide a JDBC driver to connect to the MySQL. And here you are saying which is the machine, which is the port where the MySQL is running and what is the actual database, right? So it's a standard connection URL to connect to that database using JDBC driver in Java application. That is what we are using here. Then you just say which table you want to import the data. That is a customer table. Then we will say which user and which password. So these are the parameters you are specifying in your sqoop import command, which will basically help Sqoop to connect to the source database and bring the data. Then once you want to load it into the directory, the target directory or the destination location is where? In the Hdfs. So you can give any directory here. For example, let's say I am going to give some directory name as sqoop import customers. Customers is a table which I want to import it, right? And then I am setting -m as 1. So as I explained you, instead of setting number of map tasks as 4, I can also set it as less or more number of tasks. So I just want to set it as 1. That means it will only use one thread to load the data into Hdfs. Okay. So this is the basic sqoop import command which we have to write. We don't need to do any further programming. This command I'm going to write it and I'll show you how does it import the data. So I have to open a new terminal, right? And then only I can execute this command because other terminal had this database where we can't execute this command. So now I'll execute this command to import the data. What it will do, it will create a directory called sqoop import customers in Hdfs under root directory, and then it will create a file, and then it will copy all that 12,000 records of customer data into this. Let us see how does it do it. Yes, Vishal, that is what it does. It is to import and export structured data into Hdfs. In fact, you can directly import it into Hive also. That is what it does. No other intelligence built in Sqoop or Flume. Okay. Flume will also import the data like log files into Hdfs. Nothing else. So it says it has retrieved 12,000 records. Let us go to the Hdfs and see. Sqoop import customer directory is there, under which there is a part-time file created. So if I do this Hadoop fs-cat, I should be able to see all the 12,000 records here in the file which is stored in Hdfs. Right, all the records are there. Cool. So that's how we can import the data from RDBMS into the Hdfs. Okay. We will see various other use case of how do you use a query and all that. But are you clear with this import command of importing into directly the entire table from RDBMS into Hdfs? Any questions on this? Now I'll show you the export command also. Just like import, I'll show you the export. The same data which we have imported, we can bring it back to RDBMS using export command. So let me create a table. Let's say customer. Okay, I have just created a table very similar to customers. Right, it will have same indexes, same foreign primary key relationship, everything is same, just like customer, right? But it doesn't have any data. It is empty right now. So we will bring the data from RDBMS into Hdfs. So we'll be using this export command. So let us see how do we use it. There is absolutely no difference in export and import other than the keyword export. Here it is import, here it is export. Everything else remains the same. Only thing is you just need to give the table name where you want to export the data, and you need to just say instead of target directory you need to give export directory, and you need to give the source location. So I'll be having source location as customer. Right, that's it. These are the only change compared to the previous command that we have seen. So let us execute this command and see how does it work. I'll be executing this. Again, it will be a map reduce, but it will export the data into RDBMS. So as you can see, it has exported 12,000 records. You can actually go and check it here in a MySQL. If I do select star from table, now I get all the 12,000 records in the customer export table, right? So basically, it has exported the data, all the 12,000 records in that table. Got it? So that's how we understood how do you import and export data using Sqoop from RDBMS into Hdfs. Now, I will show you a few more use cases like how do you see, we have just seen how to import entire table data, but there may be a use case that you want to just bring a set of data from multiple tables. You want to, let's say, fire a join query, and the result of that query you want to import it into Hdfs. So you want to do some other complex query, and the result of that you want to import it, right? So how do you bring the data by executing a query, and the result of that I want to bring it into Hdfs? So that I'll show you. Okay. So any questions on this, by the way? Anybody has any questions? All right. So let's do one thing. Let's take a break of 10 to 15 minutes break we'll take, and then we'll come back and we'll continue the remaining use case. Okay. I'll explain you how do we use import to import the result of the queries into the Hdfs as well as Hive. So we'll take a break now. We'll come back after 15 minutes and we'll continue further. Okay. So see you all after the break. Okay, so let me start another use case of Flume. So now we'll see one more use case on how do you actually import the data as a result of the query, all right, as we discussed earlier. So now let me write a query. Before that, I think I'll also help you understand how do you do the data table import into the Hive directly. Okay, we have seen how do you import the data into Hdfs, but what if you want to directly see that you want to import it into the Hive table? That is also possible. Okay. Under test4 database, I want to create a table called customers and it should import that. I'm specifying all the connection parameters. Okay. And then what table it is. Table is this. Or I think customers we have already imported. So let me import another table. Let's say products. Products is a table I want to import. So you can just say products. Alright, so I want to import product table into the Hive directly. Alright, so it will be creating a table in Hive as well as loading the data in that Hive. All of them will be done by Hive. So that is another beautiful feature available by Sqoop, which is directly you don't need to even create a table in Hive. Directly you can import it in Hive and then it will create a table and load the data automatically in that Hive. It's still executing it as a MapReduce. It will be an internal table, Mary. Right, so as you can see here, we were able to import the data into Hive, and it has created this many partitions in Hive. So for example, let's first go to the Hive and check what it has done. So if I do show tables under default database, I should be able to see the products table. Okay. Now if I do select star from products, it will give me all the data from the products table. And all these are products table. All right. So that's what it has brought, and then under the Hdfs, it would have created the same table under user, Hive, warehouse. You can see there is a products table, and it has these 4 files created, right? So that's how basically it has loaded the data. So that's how we can directly import the data into Hive table. Is it clear with everyone? Any questions on this? All right. So now I'll show you one more use case on this, which is basically how to, excuse me, yeah, how to execute a query and then bring the result of that query into the Hdfs. Okay. So let me show you that query. We'll be first executing this query on the MySQL database. Let us see what this query does. So again, it's the same. It is joining a customer table with the orders table, and it will find out how many orders are placed by the same customer. So there are about 12,000 unique customers are there, right? So I want to find out total number of orders placed by each and every customer in that tables, right? So basically all 12,000 customers, I want to find out total number of orders placed, right? So this is how you can do it. Customer and order customer ID, you join it based on basically a customer ID is a foreign key primary key relationship between these two tables. Join with between them and then just group by order customer ID. That's it. Okay, and take the count of total orders. So when I execute this query, let us see the result it gives. Yes, as you can see, every customer ID, it has given me the total count of orders that they have placed, right? So we are good here. We got the data as expected, right? We got each customers and the total number of orders that he has placed. That is what we got it here, right? And we want to, let's say, import this result, this data as a result of the query into the Hdfs. So how do you do that? So there is a query which we are going to use to import the data into Hdfs. I'll explain you this query. What do we do here? So you can just say Sqoop import hyphen connect to the database, username, password. Everything is same till this point, right? No changes, which connects to the source database. From there, we were specifying hyphen table parameter so that we could import the data directly from one table. But here it is specifying hyphen query, which means it says this is the query I want to import. Sorry, this is the query I want to use to basically import the data into the Hdfs. So you can see here there is a query available here in the inverted quotes. That is the result. That is the query that it will execute on the database, and the result of that data it will bring it to the Hdfs. You can also specify the target directory. Here the target directory is, let's say, query import. Query import is a, let's say, a directory that it is creating in Hdfs and load the data. But there is one important point that we need to understand here, which is, see, I had this database, okay, and this was my Hadoop box. Now in this database, I have, let's say, two tables. A customer table and the orders table. I want to join these two tables to find out the total number of orders placed by each customer. So you have to join it based on the customer ID and order customer ID column, primary key, foreign key relationship. So what you are doing, using Sqoop, you want to import it, and you are specifying a query parameter. That query will basically join both of this table and bring the result into the Hdfs. So when you are firing a join query, right, he will join both the tables, and the result of this query, which is this data, I want to import it into Hdfs. And we have already seen that Sqoop by default, Sqoop import will create 4 map tasks, right? So that it can parallelly load your data into the Hdfs because of this 4 map task. Now to create 4 map tasks, Sqoop needs a primary key column of a table so that it can uniquely divide all this data into 4 buckets. But here, since I am executing a query, and the result of that query is what I am going to bring it into the Hadoop. So how does Sqoop divides that data, this data, into multiple parts? Not possible, right? I mean, it is possible, but then you need to inform Sqoop which column to take to basically divide this data. And that's where you are actually using a parameter called split by. As you can see here, split by is a parameter which I have used, and I'm passing customer ID as a column name. I'm telling Hadoop that please use a customer ID column, one of the column here, in this result data, which will be used as a split column, so that you can split this entire result set into 4 buckets and give it to 4 different map tasks to load the data into Hdfs parallelly, right? So whenever, and I think I answered this question earlier also when someone asked this, that whenever you want to import the data from a table which does not have a primary key column, or where you don't really have a primary key column of a table and you still need Sqoop to load it in parallel manner, then you need to use a split by column, where you need to give at least one column which is unique, which has a unique values, so that it can divide it accordingly. Okay. So that's where in this result of the query also I'm specifying the split by column as a customer ID column. Okay. And then it will import it into this particular directory. So is everyone clear with this? Anybody has any questions on this portion? This is the query that I'm going to write, which will import the data as a result of the query into the Hdfs. So let me do that. Let me import the data into the Hdfs. Let me execute it. So it will fire a query. The result of that, it will bring it to Hdfs. So as you can see, the data got imported successfully. We'll now look at the Hdfs data and see the result, whether it has got all the results or not. As you can see this time I have loaded. Let me show you here. Under user okay, under the root directory itself, I have a query import. In that, there are 4 part-time files created. Why? Because there were 4 map tasks, right? By default, it will create 4 map tasks. So if you look at one of the map tasks, this was the result. Approximately 3000 records were there. If you look at another part-time file, it would have another 3000 records. So it has tried to evenly distribute the data of 12,000 records into each map task as 3000 record each, right? So as you can see, from 3000 to 6000 here, one more record. So this is how you can find out the total number of records. You can just say, this is actually a Linux command. This is not an Hdfs command. So I'm just getting the file and counting the total number of lines in that file. So it says 3000 records. Similarly, for part M2 also should have approximately 3000 records. So likewise, each map task has got approximately 3000 records, and they have loaded it parallelly into the Hdfs. Okay, as you can see, it has 3098. So that's how basically it has by default created 4 map tasks and distributed the load so that it can load it parallelly into Hdfs. So that completes the Sqoop query demo. How do you import the result of the query into the Hdfs? So is everyone clear? In fact, this covers all the use cases of Sqoop as well. Is everyone clear? Any questions on this? Yes, Mary, I have already shown you that, right? How to directly bring the data into Hive table. All right, so now we'll move on to the next topic called Flume. Very similar to Sqoop, Flume is basically helping you to import the data from any source, right, which is not having a structured data. It could be a normal data server which is keep pushing the data, or it could be a web services where you can connect to web service and bring the data, or you can actually connect to any file system and import the log files, anything. So Flume is mainly used to import unstructured data into the Hdfs, or in fact for that matter, if you don't want to put it in Hdfs, you can also put it in normal standalone console. So I'll show you one demo where we will open 2 terminals. One terminal will basically act as a source of the Flume. Another terminal will act as a sink of the Flume. Okay. So it's basically a distributed data collection service that gets the flow of the data from that source and aggregate them to where they need to be processed and then send it to the sink component. So this is the architecture of one agent of Flume. You are connecting to web service, bring the data into the channel, load it via sink to the Hdfs or any other source. So basically, This is a target location, this is the source location. So it's Flume, this entire architecture is called one agent, Flume agent. Flume will be started as one agent. So all of this, right, all this configuration of what is source, where does it connect, what is sync, where does it load the data, what is the channel, what is the configured capacity of channel. When I say channel, it's nothing but it's actually a in-memory channel which basically holds the messages. See, Flume will bring all the messages into the channel, right? So all the messages will be queued up and then it will be sent to the sync and will be put here. So the channels capacity will be configured based on what you really want it to have. Like you can have a memory channel which has some capacity, what is the number of messages it can hold in the memory, all that stuff, right? Then source means where does it want to connect, which port it should listen, and from where it should bring the data. Sync means where does it need to write the data, what is the target location. So these are the configurations. You have it in one of the configuration file called Flume configuration file, and flume.conf is a configuration file where you can have all this configuration. It's just one XML file and some command, that's it, and your Flume job is done. You don't need to write any programs, any queries to import the data. You just need to configure your XML and write some commands in Flume which will help you to bring the data into the Hdfs or into any other source. Okay, so basically this is what it does. It collects the data from nodes in Hadoop cluster, collects the data from services such as HTTP mail for process monitoring, and collect the impressions from custom applications for an advertisement network. So there are simple use cases. As I said, basically technically it can connect to any web service, it can connect to any data server, it can connect to any streaming source which streams the data continuously and then load it into the Hdfs, or you can just display it on the console itself as one source. So what we are going to do is we are going to use I'll be showing just open a sample XML file. It's not available in material, but explain that here. That you are configuring source, configuring sync, and configuring channel, and then you are just binding all the source and sync to that channel. So in the source configuration, what you are doing, you just say source.netcat s1 type bind port, means it connects to the netcat server. So Mary, basically I'm just explaining you a Flume agent configuration. Okay. Am I audible, everyone? Am I audible, everyone? Okay. Yeah, so I was just explaining a Flume, configuration. Basically, see, this is how a Flume looks. Let me repeat it quickly, Mary, so that you can understand it. I think you did not hear it some minutes. So yeah, let's just repeat it. So you have a source component, you have a sync component, you have a channel component. This completes one Flume agent. This is the architecture of Flume agent. where source will basically connect to any external source and bring the data into a channel. From channel it will be pulled by sync component and load it into the Hdfs or external directories, right? So this is how Flume data flows work. This is how Flume functions basically. But you need to configure it as a developer. You need to configure this Flume agent in an XML file. That is what I am showing how to configure it. As you can see here in this document, I have actually given a sample XML file which helps you to configure a Flume. For example, you will have a agent name something. Any agent you can define. Shaman is just a temporary name of that Flume agent that we have defined. It says what is the source, sink and channel. Just give some reference names. Then you are configuring source. You are configuring sink, configuring channel, and then binding them. So in the source, what you are doing, you are saying shaman.sources.netcat_s1. Netcat_s1 is the variable to refer to the source, right? It says .type, bind, and port. Basically, it is going to connect to the netcat server on the localhost local machine on this port. That is what we define by a source component. Then in the sink it says type is Hdfs, path is Hdfs colon this, write format is text, file type is data stream. That's it. Okay. And then you can configure a channel. Channel will have some capacity like memory, how many messages it can contain, all that stuff. Basically this is a default channel configuration. And then after sync and channel configuration, you need to just bind them. You just say bind the source and sync to the channel. So you want actually this source to be connected to this sync via this channel, right? So you are binding everything together. So what you are doing here, you just say source.netcat.channel is in memory channel and sync also points to that channel. So now both of them are connected to the same channel, so that one source will put the data in this channel, sync will pick it up from that channel, right? That's how basically a Flume data flow will work. Are you able to understand this XML? Any questions on this XML? I'll show you the demo after this of how Flume works, but any questions on the XML? Okay, so let me now show you the XML file. So I have actually created a demo on Flume. There is an example configuration file that I have created. See, it's a simple thing. Name of the components on this agent, I'm just saying a1.source, sync and channel. A1 is the name of the agent, okay? Then you are saying describe the source. So what I'm doing, I'm saying source name is R1, right? So I'm just saying R1.type. It basically connects to netcat localhost and port is 999, and the sync is logger. Logger in the sense, see what I'm going to do is, this is the exercise I'm going to follow. I am basically having two terminals. I'll be opening two terminals. One will be my source, which is a netcat server. If you know Linux, you will know what is netcat server. It's basically a simple data server. You open it and then you push the data here. You just write some text, and then whoever is listening to that server can receive this text here. So here my Flume agent will be there who will listen this, and this is basically a Flume sync component which will listen to this and then directly display the messages here itself on the console. This is why we mean it as logger. Logger means on the console itself you are displaying the result. Okay. You could have chosen it to return it to the Hdfs also, but you need little different configuration. So here if you see, In the sink, I just have logger. Instead of that, I could write some parameters to copy it into the Hdfs as well. This is my channel configuration. Let it be default. And then I am binding it. My source is actually using C1 channel. Sink is also using C1 channel. That's it. So this is the example configuration file that I have, which will connect to Netcat server, and as and when the data gets streamed from Netcat server, I will catch it via Flume sync component, display it on the console. Okay, this is my configuration file. And then I have also written Flume how to, which just says this: execute the following command. Simple. This is the command I'm going to execute it. No change here. So I'll be opening one terminal. Let me show you. In this terminal, I'll execute this Flume ng agent. This is the command. Flume ng is a command agent -- configuration conf -- conf file. Okay, I'm just giving basically the path of the example configuration, which is under this. Name of the agent is A1. Then this is just messages that you want to print. So see, I have given the sync component type as logger, which means it is going to print the messages on the console. But what type of messages? So I am going to print it as the info messages. Okay, that's it. That is what I'm going to do. Okay, I'll again show you this in case if you have missed it. This is the stuff. I'm just giving a path of the XML file. That's it. This is my path of the configuration file, and this is what I will do it. So I'll be starting this agent. So it is going to start your Flume agent, which will know how to connect to source, and it will know how to load the data into the sink. So as you can see, it says it is actually connected. It has created a server socket connection, and it is listening to this particular port. Why this port? Because as you can see here, let me just close unnecessary windows. Unnecessary, it creates confusions. Right. So I have now this also I don't need. Right. Yeah, I have one Flume agent running, and I have one file which contains the instructions. So it is basically listening to 999. How do you know it is listening to 999? Because as you could see, I have, if you have seen the example configuration, it says under this port is 999 of the source where it is connecting on the localhost machine itself. So that's why your Flume agent is started on the local host and connected to this port. So it has created the socket, so it is listening now. Okay, it will be running continuously. Now let me open another file. Another source. So this is how you can start a source as a Netcat server. Very simple. I'll just do this. What it means is it is connected to the Netcat server on the local host, and it is again, it is also opening a port on this. So whenever, let's say I'll do this, hi Jamin, if I just type this message, you would have received it here, hi Jamie, okay, on the another window on the Flume side, because it is displaying the sync component. It is actually pointing it to logger, which is a console, hence it is loading the data into the console itself. Okay. uh, Flume demo, if I just write something like this, another message came here, Flume demo, right? So as in when you type anything, it is continuously listening. As in when you send any message, immediately it will listen and bring it to the respective sourcing component, right? So you got one more message. So is everyone clear with how Flume works? The key point to configure Flume is the configuration file, XML file. Once you have a proper XML configuration defined, it's very easy to work with Flume. So is that clear with everyone how to work with Flume? Any questions on Flume? All right then, so that's what I had for today's session. We have completed Flume as well. So basically tomorrow we'll cover HBase and Zookeeper with some practicals on that, and then I'll cover the overview of remaining 2 to 3 topics. We just need to understand what it is and why it is used. So that's how we'll basically plan tomorrow's session, where HBase definitely will see some practicals so that we'll understand how do we work with HBase as a NoSQL database. Okay. Yes, Mano, that's right. All right, everyone, since no questions, I'll be closing the session now. So we'll meet tomorrow at the same time and we'll continue forward. Okay. So see you all tomorrow. Have a good day. Yeah, Nikhil, I'll also talk about Uzi tomorrow. So Uzi, Mahout and Spark is one that I will give you overview on, and we'll cover HBase and Zookeeper with some practicals. Okay. All right. Cool then. See you all. We'll meet tomorrow. Thank you.